All right, thank you, and welcome to this Eiffel Summit 2024.1. Today we will have a lot of discussions and presentations, and I think this is the first summit at Volvo. Is that right, Magnus and Matthias? Yes, that we hold that for Eiffel. And I'm so glad to see so many newcomers when it comes to the Eiffel community, but also the experts that I think one of you have been since the start of Eiffel. You're there. Perfect. Nice to see you here. My name is Magnus. I'm working at Volvo in a team called Product Metrics, and I will be the moderator for today. I think that's the word. And my task is that this summit will be as smooth as possible, run through it all these 2 days. And I'm working, and if you have any questions, please talk to me, and we will see if we can sort it out. All right, before we continue, I just want to give my sincere gratitude to everyone that has supported this summit. You know who we are. It has been a fun work, a lot to do, but I can already say that it's a success. I see so many new people, and I think this will be awesome. I'm looking forward to it. So the objectives of this summit, in my words, would be that it is connecting people and getting to know Eiffel more. And it's also a platform for learning, I would say, and not only for the newcomers that doesn't know about Eiffel, but also for the experts. When I look at, you know who you are, to learn new perspective and understand what we others are struggling with and so on. So I think it's a good opportunity for us. Some practical matters. Exits. You see the green screen there, the green exit sign. It's also that way. Lunch tickets for the ones that have signed for this summit. It's not only this box, but I have some tickets in this box that we will hand out afterwards in the lunchtime. I think we'll hand it up there, so you can eat the lunch in the restaurant there. And about the agenda, our goal is that the agenda we should keep the time as good as possible, but we have said that it might change a little bit if we see that we have really fruitful discussions, or if we see that, okay, now we need a break, it's too much, we need some sandwich, I don't know. So please look at the agenda and note if we say that we change something. Today it will be basic of Eiffel for the ones that doesn't know about it. Some topics more advanced, a QA session, and tomorrow it will be going more deep into Eiffel and advanced discussions. But enough about that. I hand over to Magnus Bäck and Emil Bäckmark with the topic Beginners for Eiffel. Thanks.
Är det på? Jo. Ja, är det på? Det var kanske andra hållet. Ja, jag mot plats. Nej, jag vet. Nu ska vi se. Skapstring. Right, so welcome. My name is Emil Bäckmark. I work for Ericsson. I'll introduce myself a bit more later, but in this session, the Eiffel for Beginners, or our introduction session, Magnus Bäck will start introducing first what Eiffel is, the basics of it. And then after that, we'll probably have our first break. We need that. and then we will have some talk about use cases. I will start talking about some use cases in Ericsson, how we use Eiffel, how it has helped us, and then Magnus will also come back and talk about some use cases for access communications. If we have time, we will also look into the community landscape before the next session, but if time doesn't allow, we will delay that for a later session. So, Magnus, take it away.
All right, thank you. Good, clicker works. So, do you work in a large software organization delivering software? And are you familiar with problems of delivering pieces of software between your different ecosystems or organizations? Perhaps you have various scripts running in different places. You have pipelines and you want to know where a particular commit is in the pipeline or how it got there, or track down errors or something like that. If so, you are in the right place. You are among friends. And this is what we're going to be talking about these days, and primarily giving an introduction in the next I think hour and a half. So I worked in the industry for about 20 years, and I worked with software deliveries during all that time, software deliveries and releases. I'm currently at Access Communications, not that well known in this part of the country, but we are one of the largest makers of security cameras in the world. We're headquartered in Lund, about 3,000 people. And right now I work with CI for our Access OS operating system, which is Linux based, and it runs in all of our devices. During the 20 years I've worked, software delivery has changed quite a lot. I mean, the whole industry has changed, perhaps even more, but still, many changes have been made. When I started, manual integration by dedicated teams of software was pretty common. You would send your changes to someone who would integrate it. We've come a long way from then, and nowadays it's usually highly automated systems where developers are in charge of their changes and their progression through the pipeline. And this has led to increased velocity of development in general, shorter time to market, shorter cycle times, and also higher quality, I would argue. And at the same time, in many cases, organizations have been growing and complexity has been growing and so on. So I think we've been doing quite well. In more recent years, perhaps latest 5 years or so, cybersecurity has emerged as a more and more important question. Supply chain security is something, you know, they talk about in the TV news basically, and responsiveness to vulnerabilities has increased in importance, and that's relevant also to what we're doing here. I started at Access 9 years ago, and back then, if you would integrate your changes, you would pass a ticket to a dedicated integration team, and you would see your change land on the master branch in maybe a day, maybe multiple days, maybe a week, who knows. There was no real way of measuring how long it took, so I don't have any real metrics for how bad it was, but it was pretty bad. Nowadays, it could take 30 minutes, maybe a couple hours, mostly dependent on build times, how big changes did you make, how many tests you have to run, and so on. So it's sort of the technical side matters. The process doesn't really introduce any significant delays. And this is despite we've been adding many more products. So we currently on the master branch produce software for about 100 products, and we have a release cycle of every 6 weeks, and that has improved a lot in these 9 years. So better for everyone, and the developers are responsible for getting the changes in, which is a huge shift. But all these changes and improvements, they haven't come without friction. In your CI systems, you probably have quite a few snippets of shell scripts or Python, maybe just 10 lines here and there, but after all that adds up in the end. And you probably have a system that could be pretty hard to maintain Maybe nobody really knows how it works. And if something breaks, you have to find the right people. I see a lot of people smiling here and nodding, so I think I'm onto something here. The use of APIs could be, dubious. You're using undocumented APIs, perhaps, or just relying on conventions that aren't really APIs. And testing the whole system is usually pretty hard for various reasons. And testing the small shell scripts is probably even harder. Now, there is, of course, lots of commercial software and open source that attempts to do this for you. And they could sell their services and claim that it solves your problems. But usually, at least if you're in a large organization, which I know a lot of you are, it doesn't really work, because the development processes are usually set. They're set over longer time. They can differ between organizations, sometimes even between teams. And finding one tool that can satisfy everyone's desire for processes around software deliveries and integration is usually pretty hard. And never mind if you're going to align it in a whole organization or between organizations, that becomes even more difficult. So usually what happens is that you end up in the situation where you do some kind of customization and you have these small script snippets that run through the whole system. But even if you would find a third-party software that would actually work and you could align your whole organization to it, is it really a good idea to align your way of working to a particular third-party tool that you might replace in a few years anyway? Probably not. So we would argue that the best way of dealing with this is embracing the changes. There will be differences between organizations. Changes will happen. You have to just roll with it and adapt your tooling to it. So interoperability becomes a key in this. And Ericsson realized this in 2012. They probably realized it earlier, actually, but in 2012 they took some action and developed a machine-to-machine language for expressing things that happen in during software delivery. And these data blobs that express things that happen, we usually call them events, right? And they developed the Eiffel language for expressing events in software deliveries in 2012. And in 2016, they open sourced a update or revised version of the original protocol. And that's where we are now. So it's been open source for about 8 years now. I think that's 8. So one of the key aspects of Eiffel is, or events in general really, is that you are broadcasting information. There's no particular recipient when you're sending these, expressing these events. Everyone can observe what happens. And this decouples the sender and the receiver, which is a pretty good aspect. So taking this to the real world, if you use a telephone to communicate something to people, that would be pretty annoying to the sender. You would have to know, who should I call? What are their numbers? What do I do if they don't answer, or if there's a busy signal? And I mean, there's a reason this guy looks pretty grumpy, because it gets pretty problematic if you have to make a number of calls. So announcing events is more similar to radio communication. The transmitter doesn't know who picks up the signal, and he doesn't care. The recipients who want to take part in the information, they're the ones who have to tune in and listen. And the sender only needs to be concerned with describing what happened in the best way possible. How can we model reality with whatever language we have at our disposal, and then transmit it to everyone. And this reverses the dependencies that you would see in the telephone case. where the sender needs to depend on all the receivers or recipients. Instead, it's the recipients who care about what information they want to receive. Now, decoupling is arguably good in general, but it's not always good. Sometimes the sender actually cares about if the recipients pick up the message and act upon it. If your house is on fire, you would probably wait until you have received a confirmation from the emergency services that the fire engine is on its way. You won't just hang up too early. So you sometimes might have to introduce a little bit of coupling if you care about what happens downstream. So this kind of broadcasting is usually done through some kind of message broker using asynchronous messaging. The Eiffel ecosystem uses RabbitMQ throughout, but if you want to use Kafka or something else, there are a number of such tools, feel free to do so. But keep in mind that the ecosystem is geared towards RabbitMQ. But I mean, you could have Kafka communicate messages to RabbitMQ and vice versa, so it's not really a an either-or situation. So these brokers act as a man in the middle for all communication. They receive messages from the producers and pass them on to the consumers. And you have two kinds of decoupling going on here. First of all, the producers are unaware of the consumers. They don't have to care, and that's good. But you also have a decoupling in time. In other words, the producers can produce at one point in time, and the consumer can consume at their leisure, because the broker queues all the messages for at least some amount of time. So the producers can keep on producing and not care about the consumers being able to catch up. And that's also a big strength. Real-time processing of these events is possible. You can certainly, act immediately within a millisecond or so of the event being produced, but you don't have to. You can if you have an outage, you can do it later. And one practical use of this is for different ecosystems to announce, for example, availability of artifacts. Some ecosystem produces an artifact, could be a container image or a jar file or anything. Could be documentation, a tarball with documentation as well. And they pass it on to the next ecosystem that could then include it in a build and in turn produce an artifact that goes downstream. And again, a strength here is the decoupling, where the first ecosystem really doesn't care necessarily about what happens downstream. And the events would serve as the trigger to, for example, include the new artifact in the build for ecosystem 2. And they would trigger their own builds. And this is pretty similar to what tools like Dependabot and Renovate do, except they don't trigger on events in the same way, but they pick up new versions of libraries and post updates to your source code to include the new libraries. So what kind of things can Eiffel describe then? Well, there are different activities going on during software delivery. You have builds, you have test executions, you could have promotions, and you could have deployments. You could also have different entities. You have source code, of course, you have build artifacts, you have test results, tickets or issues, and environments, like production or a test environment, for example. And Eiffel defines a well-defined schema, a specification, in practice a JSON schema that describes what are the different types of events we can describe, how should you use them, what is the exact syntax, and so on. And there's a strength in having a fairly strong specification here, because the point of having a common language is that it's common. If it's not common, you could just make up your own protocols, but then you would have a problem with interoperability. So let's get really specific now for once. This is what an Eiffel event could look like in the most boiled down form. So it's a JSON object. It has 3 top-level keys: meta, data, and links. So look at the individual members here. First of all, we have an ID for every single event. It must have a unique ID that's universal over time and in space. And it's just, standard UUID, nothing strange about it. We have a type and a version, and they together select the exact JSON schema that should be used for interpreting this particular event. Right, I should say that the event types are versioned individually. So, for example, it means that if the currently latest version of the events could be different, you could have the latest event of one type could be 400 and another could be 300. So don't be surprised if they differ, even if they're sent at the same time. We also have a time standard epoch with millisecond resolution, indicating when did this actually happen. I'm not sure if we really define when it's the time of the occurrence or when the event is sent. I think it's time of occurrence, but I'm not sure if we document that as well as we should. Yeah. And we have the data object, which is the one containing the event-specific data. This would be different between all event types, more or less. And finally, we have an array containing links. And that's something we're going to be talking a lot more about. It's a fairly unique feature of Eiffel, I would say. So if we go back to the activities and entities that we have here, one thing they have in common is that they have relationships. Build executions typically produce artifacts. Test executions use build artifacts. They probably test the build artifacts, and they produce test results. Deployments are made of artifacts. Possibly, and promotions are done based on, you promote an artifact based on the test results. So I could be drawing lots of lines between these. And deployments are done to environments in some form. So how can we capture and describe these relationships then? Well, let's start with a little bit of notation. We're going to be drawing a lot of boxes with rounded corners these days, and they're going to have arrows. So this would show an event on the right having a link to the event on the left. So the arrow points to the other event that's older in time. You can't point to something that's going to happen. That doesn't work. And you'll also notice that the arrow has a label affixed to it. That is the link type, because events are not only linked in some unspecified way. The links are given names or types that describe what kind of relationship is it. In this case, it's a cause link, indicating that the event on the left caused event on the right. For example, an artifact was created, and therefore we started a test execution of it. And in the actual event form, this is what it would look like. On the right, we have an event with one ID. The links array contains one item with the target key containing the ID of the event it points to, and it also contains the type of the link. So this is sort of the equivalent actual form of what maps to this graphical representation. So a key point of this is to use this for traceability and figure out what actually happened? What is the whole causal chain of events that led up to the point we're currently at? And what you're really doing is building a whole information system over your software deliveries. So if we look at, we're going to fill the screen in the next couple of minutes. Your issue tracker could issue an event, say that, okay, we have created an issue of something, describing a bug, for example. And you can file another bug, and you would have this situation. You could have a source change event that would link to these issue events, indicating that this commit solves these two issues. This is the mascot of Garrett Code Review, by the way. It's Diffie, the Kung Fu Review Cuckoo. Not frequently used. Somewhere else in your company, someone creates a container image. And you start a build in Jenkins. You're building the software in a container based on the image in question here. So you are with the event, the D event expresses that, you know, what are you building and in what environment are you doing it? Eventually, the build completes and produces an artifact. And that's something we also could express here. I should say that this doesn't exactly map to Eiffel events. This is sort of a more abstract way of indicating how you can describe your software delivery pipeline using events in general. And after the build is done, you upload the artifact to more persistent storage. We can indicate that hey, this artifact is now available here. And testing could start based on those artifacts. So I could go on, and this chain could be very, very long. When you have deliveries of artifact between ecosystems, this graph could be very, very long. And you're typically not just running one test, you are probably running hundreds or thousands of tests, possibly in different environments and so on. So keeping track of this information is not super trivial. There are, of course, specialized software for doing individual pieces of this. That's easy to find. There are lots of vendors who can, you know, sell products to that nature. But you won't have everything in one place. And I think that's one of the real strengths with Eiffel. Sometimes you don't have the same kind of resolution on the information that you would have in a dedicated system that only focuses on supply chain security, for example. They might be super good at that, but it's only an island in the whole sea of information that you have. But it doesn't have to be an either-or situation. You could have Eiffel, but also have, for example, software bill of materials, or like the small nitty-gritty details, and you can integrate references to your SBOM in your Eiffel events. So we're going to do a little walkthrough of some of the Eiffel event types that exist. I think we have in total 23 or 24 event types in total. We're going to talk about a few of them to give you an idea of sort of the building blocks you can use when modeling your system. So first of all, we've spoken a lot about artifacts. So maybe late to describe what an artifact is, but it's really any piece of data, one or more files. Typically something you build, binaries in some form, could be container images, or again, jar files or some other library, or just a set of images that you would flash into a hardware device. Wide variety. Artifacts are identified with a package URL, which is sort of standard notation of describing software packages, giving them an identity. So here are a few examples of the kind of things you can describe. Debian packages, you have Docker image, Ruby gem, Maven package, and so on. If you're not happy with these types, which are well defined and documented, you can make up your own types. That's fine as well. Or you could use maybe the generic type at the bottom, which is just here is a bunch of files. I call them this and this version. That's fine too. And this is how these work. Actually, another thing about notation here. All the events start with Eiffel and end with event. I'm omitting that from these boxes. I'm using the sort of the thing in the middle that actually is different. Otherwise, all the boxes will be much bigger and wouldn't fit on one slide, perhaps. So the artifact creation itself is separated from the publishing of the artifact. So artifact created would be the first event, and it just says that this artifact was created. It doesn't say that you can download it from anywhere. It was created. And you would follow up with a second event called artifact published, where we actually make it available somewhere. So the artifact creation sort of describes what is this. You have the identity, the package URL. You could include, if you want, file names, if you have multiple files primarily, which you often do, I think. If you want, you can include digests of the file contents. So the creator of the artifact can actually give a SHA sum of the contents. So you later on can make sure it hasn't been tampered with. The artifact published answers the question where. So it provides one or more URIs that tell you where you can download the artifacts. Now, one strength of separating these two is if you publish artifacts in multiple locations. It could be in multiple sites, or you have a promotion process where you create the artifact once and then it is promoted to different repositories over time, for example. Then it's pretty easy to see that you are actually promoting or copying the same old artifacts and not actually creating new ones. Another important thing is the activities. An Eiffel activity is something that models something that happens in the real world. An activity could be a build, it could be a test in some form, it could be really anything you want. If you want to model your team meetings using Eiffel activities, you can do that. Not clear why, but it's totally fine to do so. They're really just containers for other events, you could say. Use it to group them and give them more meaning and more context. And there are mainly three kind of events that you would have to worry about when you're dealing with activities. You have the activity triggered, that you send that when you have decided that this activity should take place. It was triggered. There you can indicate if the activity has a name, why was it triggered? Was it triggered by an Eiffel event? Was it a human triggering it somehow? Was it maybe was it a scheduled execution in some form? There are a number of different ways of expressing that. When the activity starts, which could be immediately right after, or it could be some time, you would send an activity started. The activity started event could contain, I should say, a lot of the data fields inside these events are optional. Provide them if you want, but you don't have to. It could contain the URI of the build if you want to monitor it in real time. For example, if you're on Jenkins, it will be the URL of the Jenkins build, for example, and perhaps something you could interact with. You could also provide the URI of a live log. In other words, the log of the activity, and it's only assumed to be valid for the duration of the build. It's pretty common that if you want to look at the log of an activity while it's ongoing, you have to look somewhere, and when the activity or the build has been completed, you upload it to a more persistent storage. And the live log URI is no longer valid. And when the activity is over, you would send an activity finished. The activity finished would indicate how did it go? Was it successful? Did it fail? Did it time out? Was it aborted? What happened? There are a number of different options there. And it can also contain the URI, or actually URIs of the persistent copy of the log. Of course, persistent doesn't mean that it will be valid for eternity, but at least it's going to be valid for longer than the live log. And if we imagine that we have a time axis going downwards here, we can look at the difference in time between the activity triggered and activity started. You can interpret that as the queue time. Because triggered was when you decided, yes, this is something that should be done, and activity started is when you actually started. So that's the queue time. And the time between the started and the finished is, of course, the execution time. So you could use that to generate metrics if you want. Right, and as I said, activities are usually used as containers of other forms of events. So in this case, you have an artifact created which has a context link to the activity trigger, where it describes simply that this artifact was created in the context of this activity during the activity. Now that's useful for connecting the pieces, because then if you want to have the log of the build of the artifact, you could navigate from the artifact creation to the activity triggered, and from there you can find the log of everything. So that's pretty useful. Compositions. So an Eiffel composition is a way of...
We'll continue. This is fine, sorry.
I realize that we have not said that questions is welcome to say during the presentation.
Questions are definitely welcome. Yeah.
We have this mic, and I think some will also have problem with Slack, so I think we will also monitor Teams.
Okay.
Anyway, sorry for interrupting.
No worries, no worries.
Yeah, so you have the mic if you have any questions, continue.
Yep. If your questions are too philosophical, we might want to take them in a QA session instead. It's not at all difficult to run into philosophical quandaries. So back to the compositions. Compositions are a way of grouping artifacts or source code into a group that you can give a name. Possibly also a version if you want. Right, and artifacts can optionally link to compositions to indicate what was I created from. So typically for an artifact, you would have one link to the activity where it was created and one composition link to a composition defined event that would indicate what did I actually build. And if you have, for example, multiple source repositories going into the build, you would have a composition to group those source changes into one. Yeah, that was pretty much what I described, actually. The composition here binds together those two other artifacts. So here we are describing that we are, in some form, merging the two artifacts at the top into one artifact in the bottom. Exactly what that means, I mean, that's depends. It's an abstraction after all. It's a model of reality. Tests, of course. There are a bunch of different test events that describe tests. And you would typically connect them to an activity, but you don't have to. So at the top, you would describe the recipe for the tests, the test execution recipe collection created. Here you can say, what tests should be run with which parameters and so on. And you then have test suites and test cases. You don't have to, I think, use test suites if you don't want to. You can just use test cases. Test cases would be linked to the test suites, and the test cases would indicate through an IUT link, implementation under tests, what are we actually testing. And in the end, you would have a test case finished, and yes, a test suite finished as well, similar to an activity finished, indicating how did it go? Did it pass? Did it fail? Did it time out? Is it inconclusive? Maybe we don't know how it actually went. Probably unusual, but it's possible. And similar to the activity finish, you can also provide logs. And it's the same thing as with activities. You have both the live logs and the persistent logs of the test execution. Confidence levels. Confidence levels, they describe whether or not a particular, typically an artifact or a source change, do we have a particular type of confidence in that thing? So a confidence level modified could express that this artifact, we have confidence that the unit tests passed, or that some kind of system test passed, and it's ready to be released to a customer, for example, or not. It could also fail to achieve a particular confidence level. Confidence level could be sort of nested, where you have maybe one confidence level is based on other confidence levels, where you can express that if the unit tests pass, the end-to-end passed, and manual tests, those confidence levels were achieved. In that case, we are ready to release to a customer. Right, yeah, that's pretty much the example here. So we could have on the left, we could have the unit test. On the right, middle right, we would have the end-to-end tests. And they would point to the artifact describing this is the thing we are expressing our confidence about. And at the bottom, we have the confidence level modified that points to the other confidence levels and say, based on these conclusions here, I now conclude that we are ready to release this to customer or not. Source changes, finally. Obviously, source code is pretty much key in all of this. And there are a couple of different events that describe source code events. This is something we have been discussing at the summit last year. For those of you who were there, we discussed it in the summit before that, and possibly the summit before that. Modeling source code using events is very hard, it turns out. So the current source events, I would say, are subject to change. But for now, they look like this. We have two events: source change created and source change submitted. Source change created basically means that there is a change somewhere. It could be a change in Garrett, it could be a pull request. It's something that exists but hasn't really been merged into a branch quite yet. And then the submitted would indicate that this is now available on a particular branch, for example. And apart from linking to each other, where the submitted event links to the creation, you could also link between events of the same type. So you could basically build the complete Git repository graph using these events. We do that, for example. It's a little bit tricky and it produces a lot of events, but it's possible. And thereby you can navigate the source graph without going into the Git repositories, which is pretty convenient. And that was it. And I think we will take a break now, Philippe, and we will continue after the break with the Ericsson use cases. Yeah, muted there.
Am I on? You hear me? Yeah, good. So I think we take some time for questions, please.
It was fun.
Was it on? No? No?
No?
It was working.
It is working. You hear me?
Speak up, sir.
I'm speaking up, okay. You hear me well? Okay. So I think we should force through some questions. You must have some questions. I mean, we have some time before the break. Or was the message that clear? Come on.
Start doing this from scratch. Where do you start? It's a huge change, right?
Yes. Yeah, that's a really great question that I talked about in an earlier presentation in an old summit, but I didn't include that here. But yes, I think you have to sort of start with what's your goal? What is your end goal? Sort of what events do you want to see in the end? How do you want to use them? And then, work your way backwards. Sometimes you could have, you don't have to go all the way back. Perhaps, you don't need the source change events, for example. You just want to see, maybe just want to express confidence levels on artifacts and use it to describe release decisions, for example. Then you don't need all the thing, way back in time. And then you might actually need the source changes, and then you have to sort of work your way backwards. So it depends on what your end goal is and what kind of resolution of the data you want. For example, if you, in multiple events, there are ways of referencing sort of external sources where, so I mean, one option could be that you reference a description of something in another system rather than describing that same thing in Eiffel. I mentioned software build materials a while back. For example, you could, instead of describing the whole software build materials with Eiffel events, which is possible, you could just link to the SPDX or CycloneDX file that you have stored somewhere that contains the same information. So it sort of depends on the end results. Do you need that information described in Eiffel events, like source changes? Do you need your whole Git graph in Eiffel events? Maybe not. In that case, you don't have to generate all those events.
But to complement, just start small. That's also the thing.
Yes.
I think start small and grow your setups over time. Start with use cases that you think would provide most benefits in the beginning, because it will take some time to set the infrastructure and everything. So don't expect the full-blown solution from the beginning.
How do you eat an elephant bit at a time? Yes.
Do you have an ecosystem or tools built to consume these messages? So for instance, you talk about confidence levels, but the way to display those and stuff. Is that up for us to build, or is there tools already available to do that?
There are, that's something we're going to talk about later on if we have time. So there are definitely some tools, not specifically for confidence level aggregation. There's nothing pre-made for that. Because it probably, I think it would be hard to do something generic for that, but there is a set of tools generally available. But you should be prepared to write some own code as well.
We recently started using a little bit of like events. And you showed the broadcast analogy versus telephone call, but getting into it from our end to setting up a new queue on the Eiffel server and access rights. A lot of stuff that you typically don't have in the radio broadcast. So I mean, it wasn't a broadcast, it was back to a handshake with the team that sent you that, we need to read this event from that queue on your private empty server. Is there a better solution for that, or?
I think that's something we're going to talk more about tomorrow, actually. But in general, I would say, it sounds like you have compartmentalized your events a little bit too much. And you should probably just open it up more. if possible, for confidentiality reasons.
And do you waive the authentication on Revenue or is there? Or
You would have to use some kind of authentication and probably lock down who can publish, but yes.
Yeah.
I mean, if possible, and I think most events are designed in such a way that confidential stuff is usually kept out of it. So, for example, the source change events, it only says it contains the name of the repository, the commit ID, and so on, but it doesn't contain the commit message and things that are more likely to be sensitive. So in most cases, it should be fine to have pretty public events. There are ways of locking it down, but Matthias is going to talk about that tomorrow. But I think you want to avoid it if you can.
And I have a question.
Yes.
Source. So for us, we have what is a source? So now you write source code, but I guess other things can be source as well. Like if you have you specify something, or you have it doesn't need to be code, or doesn't.
The source in this case means code.
It's always code.
Yes. If you have like a specification. Like, yeah, a specification I would say that would be an artifact that sort of already exists. So if you get a specification from like a third-party supplier, you could register that as an artifact. Of course, if you check it in to a source code repository, you could, but it's still, then it's just, no, I would say that's an artifact.
Okay.
And you would then specify where you can obtain that artifact. And that artifact could be part of builds, or I mean, it could be tied into the whole graph if you want.
Yes, for one word, I'm thinking of software configurator, if that is a source or if it's an artifact. That's why I'm asking the question. But thanks.
You find it easier to do health monitoring on the whole production chain for different build? Can you use this for that as well? To see where the problems occur, to address them quicker? Because that would be a huge gain to fix, the production line, so to say.
You could probably do that. I don't know if you have done it. I haven't, but
Not really, no. There are thoughts about it, of course, and we want to combine this metrics or this data coming from the CI/CD pipeline with metrics data or telemetry data coming from the actual systems that it's running on. We're not there yet. We're talking to the OpenTelemetry community about it, so there is a collaboration somewhat going on there. We hope that will result in some good common ground where we can ease the troubleshooting of the whole system, including very low level problem finding.
Yeah, because that's a huge source of cost when the system is down, so that's probably I think it's as soon as we can.
Please contribute.
sure, it depends on what kind of health you're referring to. But I mean, if you have, if you produce, for example, artifacts, you should be producing them with some kind of cadence. Or if something happens over here, we should see a test result over here in some kind of time. Yes, you could fairly easily do that. And it might be better to monitor. In general, I find when making software, instead of alerting on errors, alert on the absence of correct results. Because I mean, if nothing happens at all because the whole data center blew up, you won't get an alert maybe. Nothing happens, but you won't get any errors. So
you can set up an alert to figure when something is missing that we were expecting.
yes, yeah, exactly. I mean, you have like a heartbeat. I want to see this kind of artifact. I want to see it every day by some certain time. If I don't get it, do something.
Then you could build the
Yeah. Good.
So I think we're done with the introduction. I would like to just have a show of hands. I mean, we are quite a lot of people here from different places. Could we just see who is here from Ericsson first? I am. Few ones. Who are here from Volvo Group, including consultants? Quite a lot of people. I didn't add the consultant to Ericsson. Are there any consultants to Ericsson in the room? Which I didn't raise their hands before.
You want from Access? Yes.
Access Communications, one. Tieto Every, one person. Do we have a representation from 3M in the room? Okay. Anyone I forgot? Any other organizations? No. Great. Nice to see you all. One thing that we didn't mention in the beginning, we have a whiteboard over there. It's intended for jotting down your ideas on Q&As or questions rather than answers, I guess. So don't be shy, go there and post all your questions. We will use them then in the Q&A session in the afternoon. Of course, you're free to come up to us during the breaks as well and discuss directly, but if it's something you think is worth for the whole summit to discuss, then bring it up there.